Now to 6.6. All right, 6.6, what are we doing? We're solving the matrix equation. These will be super easy. Let me show you what to do. I'm just going to, they're going to show you something totally different. I just think, who cares? Just do what we did before and do RREF. Remember how we did that before? Just plug it in. Want to do one? Yeah, just enter that as one, just put that in as one big matrix A. Yeah, just a 2 by 3, and then do RREF. That'll handle it. That's what it means to solve for X in a matrix equation. There's more theory. At different semesters, I've taught more theory. But there's something else I want to see, which is a really neat application. I want to show it to you. So just type that in real quick, and we'll be done with this one. Type that in. It's a 2 by 3. So you type it all in. You enter matrix A. You quit it, and then you go, remember how this works? You enter A, you enter matrix A, and you second quit. And then you do second matrix, go over to math and down to RREF. Remember how to do that? And then go second matrix, and on matrix A, you just hit enter, and then you just hit enter one more time, and it'll solve the whole thing. Remember that process? Go over to math, down to RREF, then second matrix, enter A, enter one more time. What I got when I did all that, I got the following answer. 1001, there's the negative 25. So the answers are negative 25. Did you get that? Yeah. There's your answers right there. So just do RREF. Just do what we did before. Don't do their new thing. If you type in the help, show me example button, they'll show you some new thing. Whatever. We'll just do it the old way. Good? Okay. So what would you do on this one? You would just type in negative 2, negative 1, 7. There's a 0 here, huh? 0, 4, 5, negative 7, 3, 6, negative 40, negative 4, negative 40, RREF. Does that make sense? Just make it one big old matrix, RREF. Reduced row echelon form. And you'll get your answers. Sound good? Nothing new. We did that in another section. Just do the same old thing.
That's the inverse. RREF.
RREF is not quite the same as inverse. It's reduced row echelon form.
Because it's asking for it.
Yeah, I'm not going to do it their way. Oh, are they asking for? Oh, yes, they are. Yeah, never mind. Okay, so let me say, whoops. This number 3 is no longer here. So this is no longer your number 3. They won't ask you for the inverse. So instead, what's the real number 3? Here's the real number 3. This is in your homework. Just type it in RREF. Sound good? Yeah, because they're not going to. That's why I got rid of it, because they were asking for the inverse. And I thought, I don't want to mess with that. All right. So that'll be. Okay. An electronics company produces transistors, resistors, and computer chips. Each transistor requires 3 units of copper, zinc, glass, copper, zinc, glass, copper, zinc, glass. How many of each of the products can be made? Copper, zinc, glass, blah, blah, blah. So it's one of those word problems like we've been doing. So you need to just do so that whatever they're asking for, though, that's your X, Y, and Z, isn't it? So I'll put transistors, resistors, computer chips. X, Y, Z. That's at the top. And then the other qualities go down the side. What are those? Copper and zinc and glass. Right? And for the copper, so go up here to the copper. So for the transistor, which is X, 3 copper, 2 zinc, 1 glass. 3, 2, 1. That's all for transistors. So it went down. That's for X. Everybody tracking with me? And then for resistors is the middle. It's 3, 1, 2. 3, 1, 2. Good on that. And then for computer chips, it's 2, 1, 2. All right, good. And then finally, the totals. It says 2455 copper, so that goes here on the copper line. 1350 zinc, that goes here. 1380 for glass. Put that in your calculator, RREF. Good on that? Is that okay? I move on. I want to get to homework. So has anybody worked on the homework already? You guys on it right now? Okay, so then once you're on it, it won't let me cut it out. So that's what I'm asking. So let me just write a note. Skip number 6. Just skip it. Don't worry about it. Even though it'll tell you your homework's lower, I won't count it against you in overall points. Don't worry about it. So just skip number 6. I don't want to do coding. I mean, we just don't have time for everything. I want to show you, though, 7, 8, 9, and 10. These are valuable. This is kind of a neat application of economics here. The production matrix for the following input, output, and demand matrices use the open model. So let me give you a formula for these. These are kind of cool, I think. Basically, it's I wish I had got here quicker and had more time to explain. But basically, it's a way of modeling how economic systems work using matrices. Actually, a guy who got the Nobel Prize, I don't know, it was 20, 30 years ago, for basically looking at how economic systems work and modeling them with matrices. Basically, the long story short is, what he noticed is that, suppose you got like agriculture. You got an economy, and you got agriculture, and you've got assembly line. Well, what they produce, what the agriculture of your nation produces, what the assembly, the factories produce, is not all directly output for the consumers. Why? Because the ag industry uses some of their own ag to feed back into making more ag. And the assembly people use some of their assembly to feed back in. What do I mean? Well, like the ag department, they use a lot of the food they grow to feed the cows to make more ag. So in reality, if you want to figure what the agriculture for a nation is going to produce for consumers, you got to realize that you got to take out what the ag produces and uses itself, and what the factories produce themselves. So you end up taking these matrices and multiplying them by themselves, and it's a long process, which now I've used up all of our time to explain in more detail. But it's very interesting how the matrices are used to calculate economies and how they're going to feed. Let me just give you the formula so you can get through your homework. We'll crank through. This is the formula you're going to use every time in these questions. There it is. Let me get this out of the way here. There's the formula. Now, what is this? X is the amount produced. The amount produced for the amount, let's just say the amount produced, the total amount produced by the country. Okay, D is the amount available as demand. The D stands for demand. As demand to the outside, the consumers. I is the identity matrix, 1, 0, 0, 1. Remember, that's the 1, that's the unity element. I stands for identity matrix. It's the big fancy 1. 1's down the diagonal, 0's everywhere else. And they're giving you A. So type that in. So how are we going to actually go about doing that? You've got to do the following thing. Enter A and then quit. So step 1, enter A and quit. Step 2, enter B as 1001 and then quit. So enter A into your matrix, and the A is right here. This is A. Enter A and then quit. Enter B and then quit. And then enter D and then quit. You got to put them all in there. A, B, and D. B is going to be your identity. So A, B, and D. You know what I mean by enter them as a matrix? Store them, edit them, put them in. So enter matrix A. Let me get a fresh screen here real quick. I can write this a little better for you. So here's the steps on these demand ones. So step 1. Enter A as 0, 0.2, 0.25, 0.4, and quit. Step 2. Enter B. B is going to be the identity, and quit. Step 3. Enter D, the demand matrix, which is 3, 4, and quit. And then on the main screen, you're going to do that formula I just gave you. You're going to do parenthesis B, that's your identity matrix, minus A, and you're going to hit x to the negative 1, inverse, times D. Enter. You're going to do a big matrix calculation. Do you see that? So you're going to enter matrix A, B, and D, get them all in there, and then on the main line, put that in as your matrix calculation. It's how you calculate what the economy, what you need to tell, what the government would need to tell agriculture and manufacturing to produce in order to have the desired demand for consumers. Because some of their product is used up in processing. That's the point. It's not obvious. It's complex. So is this making any sense? So put in A, put in B, put in D. Store those, and then do this big line. B minus A with, you need those parentheses. Matrix B, remember how to call forth a matrix? Right? Do all that. So
Minus 1 is the power.
this is x to the minus 1. That's the inverse. That's the inverse button. You're inverting the whole B minus A. Wait, did I do that right? Yes, correct. Yeah. So correct, because it's the parentheses, it's B minus, B is the I, that's the identity matrix. It's the whole B minus A inverted here. That's what that is. That's the inverse button, which is the matrix key, right? Times D, enter. All right, put that in. So we good getting that all typed in? Got matrix A in there? Everybody's got A, B, and D in there? And then do this line. You're naming them. Show you. Oh. Bump it. There it is. Did you get those answers? Yeah, that's the right answer. See what I did there? See how I put parenthesis B minus A, parenthesis to the negative 1 power times D, and hit enter. I got those two answers. You all able to get that in your calculator? You're going to call those forth. You're naming each of those. Each of those is second matrix, and then it's under the name. You're naming it. You're calling it for like a magic splash. I'm naming B, come forward. A, come forward.
I keep getting an error. I don't know, my head hurts. My head hurts. I'm doing the one on my screen.
Right. So see how you do it? You don't have any parentheses?
Oh, I have, oh.
So does parentheses really matter? Got to have parentheses around B minus A. Is that good? Other things I can say to help? Is that making sense? So what is that? That's the amount. So if we go back to the main screen, what that means is if they've got to produce 4.73, whatever that is, tons of whatever, and 8.64, in order to have demand for the outside public of 3 and 4 tons or whatever. They got to produce more than someone's going to be used up in production. That helps you calculate what that's going to be. Same formula every time. So we read this, and we go, as soon as you go, blah, 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 oh, depends, input, output. This is input. This is called input, output analysis, economic analysis, input, output. Because production, they take in some of what they produce. See, that's the tricky part. They take in some of what they produce. So input, output. So there's your matrix A. And you're going to use the identity element always. And then what's your matrix D? What's the demand? There it is. Demand, 580, 820. So 580, 820. Then just use the same formula. It's going to be, this will be B, right? B minus A inverse times D enter. It's the same thing. We just keep using that same formula. See how I got the D? I just looked up here at the word demand. Demand, 580, 820. 580, 820. And they gave me A, and we always use B as the identity. Is that making sense? Same formula every time. Cranks it out. Let me look real quick at 9 and 10. Make sure those are good. Everybody good with that? Same exact thing. So saying, all right, private economy, 2 basic goods, yams and pork. Okay, basically, I'm going to put yams and pigs, porks, and yam and pigs. Okay, 1 bushel of yams is a 1/8 and 1/3. So they're telling you the numbers in the production matrix. And 1 pig is a half. Oh, just a half of yams and nothing there. That's the A matrix. They just told me the A. The demand to get, that's demand, 250. Same formula. It's going to be B. B will be the identity matrix like it always is. B minus A inverse times D enter. See how I read that off? That A matrix? It was telling you how you use yams and pigs to produce yams and pigs. Right? Pigs eat yams, I guess. You need yams to produce pigs. So when you're thinking, how many yams is our economy going to produce? You don't just set the number. Part of those yams are going to be eaten up by the pigs that you're producing. So you see, the things you're producing kind of intertwine with each other. And it's a little complex to figure out what the final output's going to be for consumers and what you need in your country. So these matrices help you calculate all that. That's what that's doing. All right. I should have gone quicker in the beginning. Sorry.